So working, is it on? How are we doing? This is going to be an interesting stream today. So to start, we're going to go with flip square matrix, submatrix vertically. Looked at that the other day, briefly. Let me check and see if stream is live. It's working. So, excuse me. The idea here is I'm going to try to spend about 8 hours today on LeetCode and live stream it. It should be good. So we have, I talked about this the other day. I'm gonna summarize it quickly. Basically here, we've got to flip row by row, reverse the, a sub matrix within a matrix, which I think is not too hard to do. Let's see what this looks like here. How are we doing? Yeah, it's gonna be some buffering, it seems. Just make sure it's working, which I think is not too hard to do. Okay, seems okay. All right, great. So we'll keep going here. All right. It's a very simple thing. Let's do a reverse routine. I'm gonna write a custom reverse routine. I'm just gonna do a swap from back to front, and we're gonna say for each. We're gonna inline it basically. I'm gonna say for. Going to return the grid itself. We're going to do this in place. We're going to say so x and y and k is x and y are row and column. It's row column coordinates where k is the length. Okay. All right. Let's do row by row. Int I or column 0. Column is less than k. Increment column. Or we'll say I. We could do I. It's actually fine. And we're also going to increment column, which is going to start off at x. It's going to start off at y. And increment the column. So we'll go column by column. Then we're going to do the reversal on through the arrays. So it's going to be from j equals 0 row. It's going to start off at x. J is less than k. Increment j, increment row. And the way this is going to work is I'm going to std swap grid of it's going to be row and column with grid of, so this is going to be jump ahead by k amounts. It's going to be like row minus k minus 1, something like this. So when row is 0, or excuse me, k minus row, oops. So it's not actually row, it's j, and it's not k. It's going to be, it's more like x plus k minus j minus 1, which is a little bit confusing. Yeah. So when row is 0, or when j is 0, you've got two elements to look at. It's going to be x on one side, and then it's going to be, should be x plus k minus 1, right? Because k is 3. So it would be like if it was, let's say it was 1, 2, and 3 were the row indices. X would be 1, and then k is 3. So 1 plus 3 is 4. Minus 1 puts me back at 3. So 1, 2, 3. Yeah. So there's a minus 1 there because it's k is a it's the size. And then I would subtract j because I'm going back upwards. So it's sort of x plus k minus 1 minus j, which is a little bit confusing. I think this is all you need. I think that's all that's required. I could be wrong, but I think that's it. Wrong answer. Okay. So oh, and there's one more issue here. I only need to go to k, yeah, half of k. I don't need to go because I'm swapping both sides. I don't. If I did, yeah. So I'm gonna submit this one. I think this is correct. If I this might be wrong actually. This might be off by 1. No, it's right. Yeah. So, and it's relatively efficient. I could run it a few more times. I'll probably get 100%. The reason you do halfway is if you swap all the way through, if you go down all the way to the bottom and swap all the way through, it does a double reverse, which is not what we want. We just want one reverse. So that's why you go halfway through. Because the way the swap works, it swaps 2 elements at a time. And so if you do a full clear, full all the way through, it's going to swap twice the elements that you need rather than just one. That's a fairly straightforward solution, not too hard to understand or explain. What are we doing here? Okay, a lot of buffering, still a lot of buffering. Okay, special binary string. Okay, so this one's a hard, but I think this is on the easier side for sure. So this one's going to be binary strings with the following 2 properties. Number of zeros is equal to the number of ones. Prefix of the binary string has at least as many ones as zeros. Okay, very interesting. So the prefix has at least as many ones as zeros. So it could have more ones than zeros. But so basically each time you see a 0, you're going to see at least 1 or more ones. So it's kind of a front-loaded string to an extent, which is pretty interesting. Move consists of choosing 2 consecutive non-empty special substrings of S and swapping them. Okay, 2 consecutive non-empty special substrings of S and swapping them. 2 strings are consecutive if the last character of the first string is exactly 1 index before the first character of the second string. Okay, so let me see here. Move consists of choosing 2 consecutive non-empty special substrings of S and swapping them. 2 strings are consecutive if the last character of the first string is exactly 1 index before the first character of the second string. Return the lexicographically largest resulting string possible after applying the mentioned operations on the string. Okay, interesting. So they're binary strings. The largest resulting string after applying the mentioned operations. 2 consecutive special substrings. Oh, wow. Okay. So here, these are both special substrings. They're saying that you could swap this one with this one, I think. And if you were to do that, you would get 11010 here. Oh, excuse me, it would be, excuse me, they have to be exactly equal to be special. But every prefix has ones in front, so you'd have to swap all the way across here. So 110010. Okay. Lexicographically largest string possible if there's some number of swaps. Okay, this is an interesting question. This is considered hard. So I think this is actually a greedy approach, works pretty well here. I think basically you can use give me 1 second here. You just find the first special substring from left to right, and then of all of the special substrings that follow, which you could do this in quadratic time. S is kind of small. I think you could do it in quadratic time. You find the first special substring on to the left, from left to right, and then you look to swap it with the special substring that has the most consecutive ones. And that's basically it. Can you do it in linear time? You probably can do this in quadratic time, I think. You could just check at each index from left to right how far you can go. Do I need... All right. Are these multiple operations or just one operation? Actually, I'm not really sure. Let's do 10111000. What I get for number 3? Actually, not sure what their outputs are, what they're expecting for the outputs. Okay. So they expect this. Now, what about if there's another one? How about this one? Okay. Okay, this is kind of interesting. So okay. How about this one? What does this look like? Okay. So this one we have the 3 zeros, and excuse me, 3 ones and 4 ones. And I would expect to swap these. Four, 3, 1. Okay, so actually, it looks like I'm supposed to swap all of them, not just one swap. So if I have this 1, 2, 3, 4 here, this is going to swap with these 3 ones, but it doesn't just stop there. Those ones are that 1 0 is going to swap with these 3 1s as well. Okay, that's interesting. So, yeah. Okay, it's not obvious actually how this should be done. Let's say, also, how am I doing with buffering here? It's considerable buffering. Okay, so it's not obvious how to do this. I mean, I could sort based on basically I could run a sorting routine. I'd want to break the string into tuples, basically tuples. Or actually, I can do it this way. I don't need a tuple. I can get a prefix array. No, yeah. Well, yes, that does work actually. So I can do a prefix array of ones and zeros, or just ones really. So I can calculate, given a range of the string, how many ones I've seen so far, or how many ones are in that range efficiently. So I can use a prefix array, and then I can also obtain a starting and ending index. And then I can sort the starting and ending indices based off of the computed value of the number of ones. I'm not sure if that's totally correct. I actually think a better approach is um, hmm, um, thinking a better approach is let's give it a moment here. Thinking. That's a lot of buffering. A better approach is Hmm. It's actually the what's tricky here is I could do string comparisons directly to get the lexicographical sort, which actually might be more accurate, more correct. Yeah, I was thinking about just doing the prefixes themselves, but you could have something like 111001 or 111010, or excuse me, 0010, 111, 111, 01, 0, 0, 0? Yeah, basically, it could actually get pretty complex. It might be easier actually to use a lexicographical sort. So this is a little more complex than I was thinking. All right, let's try this. Let's do it this way. So let's say stud vector of std string specials. And we could say specials.reserve 50. And for each int I is 0, so we're going to say I is 0, I is less than s.size, I. I'm going to say int ones 0, 0 is equals 0, j equals I, increment j is less than s.size. And we're going to say ones plus equals s of I const char ch, or bit. It's going to be yeah, it's a string, so it's s of I minus 0. Oh man. Okay. My computer lately, I think it needs a restart. I'm thinking I maybe should have restarted the computer before I started this. Anyway, okay. Bit is, so if it's a 0, it'll be 0. If it's a 1, it'll be a 1. Okay. And we'll say if ones equals zeros, break. Okay. So we'll start at some index I, and then we're going to loop j across left to right. And we're going to add the 0 bits, add the 1 bits, and add the 0 bits, or count the 0 bits and the 1 bits. If they're equal to each other, then we can stop there. And actually, I'm going to build a string. Temp string. And I'm going to say temp.pushback. Specify. Okay. So when they're equal, then we break. And then I would say set I equal to j. And probably increment I one more time as well to start the next sequence. And before I do that, I'm going to say specials.pushback temp. Yeah, I mean, this could be a move. Okay. So this will give me the specials. Come back to that, whether or not that code is correct or not. Then we want to sort specials, which a regular sort should work fine here. And then I want to have the resulting string. This actually should have been s.size, not 50. This also, yeah, okay, it's fine. I could think about pre-allocating this memory. I'm not sure if I need to do that though. And then now we just build result. So we would say for const auto s string and specials. Just say result plus equals string. Return result. Something like this, I think, is correct. Could be wrong though. That's actually not in the right scope. Wrong answer. Okay. Okay. Huh. All right. Oh, it should be S of J, not S of I. That's a mistake. That's kind of an easy mistake to make. Okay, not correct, but correct on this case. Not correct in these other cases. So let's go with one at a time here. It looks like I returned exactly what went in. Hmm. Hmm. Still buffering. Let's see. Yeah, still buffering a bit here. Okay. Let's do this. Let's print special. Just do some debugging here. See what this looks like. Okay. So in my output, one, one, zero. Oh, okay. Hmm. Okay. Interesting. So that's interesting. Let's do it this way. Oh. Huh. Hmm. Ooh. That's not the right logic for this. The logic that I'm thinking of here is not going to work. Hmm. Um, hmm. There are a few things that need to be resolved for this to work, actually. First things first, actually finding the substrings that are special. That probably should be done in quadratic time. And the reason for that is actually the entire, I don't see an easy, greedy approach because the entire string is special in this case. If I tried to use what I used here, it would basically just return the whole string as a single entity. Whereas I actually need to get all of these substrings. And not every substring is going to be going to fit this category. Excuse me, it's not going to have this property. Oh. I mean, I could do that directly and get all the special substrings. Then the question becomes, well, what do I do with that information? They don't necessarily overlap, but they do have a kind of a hierarchy. So like this whole string has two subchildren here. And the issue, and the children are not going to overlap on the same, I guess, on the same hierarchical level. One of the problems here, though, is reorganizing those sections. There are potentially elements in between, characters in between, bits in between. There are potentially bits in between that need to be addressed appropriately, properly. So in this case, this 1, 0 and this 1, 1, 0, 0, when these two are swapped, this 1 and this 0 are untouched, which is not the simplest thing to program. And if there are any bits in between these two, there's like maybe a 1 and a 0 or something. Somehow, if there was an extra bit in between. Although I don't know if there will be. I don't know if that's true. I mean, you might be able to prove that there won't be. Between two special binary strings, can you show that there will never be a bit between them? I don't know if you can. I'm not so sure about that one. I think, that's not so obvious. Oh, I gotta think about it, huh? Yes, I do. That I do. Why does that matter? I basically would need to ensure that, so I can still get the substrings using brute force, sort of brute force. The substrings that are special, and then excuse me, can sort them lexicographically. That's fine. Yeah, that's fine. Then the result would basically use those strings in sequence. But it would have to not use the strings that are untouched, I suppose. Or else I need to resort them by their length. The longer ones would be the ones that come first. slight variation on your typical lexicographical sorting. And then I think the greedy approach is fine. I would just use each of those subsections. I guess I would pick from left to right. I'd greedily pick the subsections that I'd want to use, and then I would need to identify the characters that are untouched. That are not in any of those sections that I picked, and maintain the order of those characters while I basically swap around and insert. Excuse me. I should have pressed the button. I have a button I could press. Not make that so uncomfortable. I think this works. I think this approach works. It's just a curious thing here. Damn, 8 hours straight in the car. What's up, Kanav? Crazy-o. Well, in my home. But 8 hours, yeah. You bring that up frequently. Each time, half the time I see you, I think you mentioned that. But yeah, so let's say, okay, so I think this works. This approach works. It's I don't know what I meant. What did I say? It's going to be find the substrings that have this property, all of them. The strings are only size 50, so it's reasonable to do this. Then I'm going to sort those lexicographically, those substrings that have this property. So save all the ones that have this property, sort them lexicographically, but then also sort them again, maybe a stable sort. I could sort them in both directions, sort them by length and by this lexicographical property. So the length would take precedent. But if they have the same length, then sort them lexicographically, whereas the longer ones will come first, because those are actually going to be more meaningful for this question. Then I can greedily select from the strings that I have, left to right, in terms of lexicographical, I guess, it's not really size in this lexicographical position. I'm not sure what to call it. Lexicographical order, that's the word. In terms of lexicographical order, yeah, in terms of lexicographical order, I'd want the ones that are smallest lexicographically, but also have the longest length, and pick those greedily left to right, because some of these are going to overlap. And then once I've got that sequence, then I can identify the character indices that are not in that, like if I took the union of all those intervals, the ones that are not in that union, and then I would write The writing part is not so obvious. I think I could just make a string, maybe like a queue, basically, of those characters that are not used. And then I would write, so this is where it gets kind of awkward. When these things are swapped around, they're different sizes. So characters that are in between, or to the left or to the right, kind of end up all over the place, potentially. It's not obvious where they end up exactly. So I think it's I gotta think about this. Let me close my eyes for a minute. I'm actually suddenly got very tired too. mm, um, sorry, my mind is like somewhat elsewhere. How can I do this? So I can figure out which pieces I want. Let's say I had like A, B, C, D are different chunks of strings. I guess that's what I would need to do. I would need to, like, once I have the sequence that I know that I'm going to use, it's a permutation of some of the characters in the string, and the other characters, other sections, need to stay in the same place that they were in originally, but not exactly the same position, just the same relative order. So I think that's kind of the issue here, is that I need to think about breaking up the string into several different pieces, and the relative order needs to be preserved. Okay. I could maybe do it that way. I could assign each of those substrings an integer, an index, and then I would sort the intervals that I'm interested in and give them new indices, basically give them new indexes, new indices. So I would basically reassign the indices of the intervals that I'm interested in, the intervals that I've sorted. And then that gives a relative order of where these should appear. Um, hmm. Interesting. Does this make sense? Huh. Um, Almost. Tuples are immutable, I think. Let me see. I'm wondering if I could use a tuple. I'm not so sure this is such a thing that I could do. Um, Still thinking about this here. So, how are we doing with a lot of still, yeah, buffering, a lot of buffering. Um, yeah. Um, okay. Tuple is actually mutable. Oh, okay. Oh, I think it's tuple. Is there tuple or tuple? I think it's tuple. Could use a struct. Okay. Stud array, maybe. Hmm. Okay, we'll use a stud array. I gotta think about this again though. Like, it is a lot more complex than I was originally thinking of. Um, so okay, the approach is going to be take the substrings, perform the check on each substring. Actually, that's technically cubic time, not quadratic time. It's quadratic number of substrings, but cubic time. Well, I could do them in a sequence that allows me to do it in quadratic time, I think. But yeah, I would check the special substring property. From left to right, for a starting point, how far I can go. Um, yeah, save all those subarrays that are special substrings. Ooh, excuse me. Yeah, there could be more than one special substring at a particular index starting point. So that's, yeah, okay. So then I can, could save those as instead arrays as starting ending points, as well as indices, which the indices could be -1 initially. And then I can sort those lexicographically based off of the length and I think I mentioned the lexicographical values for those strings. I guess I would use a string view. Let's see. Would it be reasonable? Just to sort lexicograph. Should be indices actually. But let's see. Oh wow. Okay. Huh. Hmm. Nice. Okay. Hmm. Huh. Yeah, it's kind of tricky. Think yeah, I think something's up with my oh no. Okay, this is good. All right. Gosh. Hmm. Still thinking here. It's pretty tricky, huh? Getting the substrings in quadratic time is fine, I think. And then, as I mentioned, sorting them, but basically getting the beginning and ending indices is probably better. I could sort them as views, but I'm not so sure about that. Maybe a pair of views. I could try that. A pair with a view and an integer view pair. Maybe a pair of step view. Array of substrings. A new challenge to organize the original string selected strings. Between I'm not really sure how to explain this or express this. This is like kind of a weird thing to express. Stable reordering problem. Yeah. It's an excellent choice. Okay. Reconstruct the original geometry of the string after sorting. Selected intervals, fill intervals. Sort your selected list based on your greedy criteria. String view and custom comparator. Reconstruct, iterate through the fill intervals, which act as fixed anchors, and interleave the sorted selected intervals and the gaps between them. Store your selected substrings with the original index to maintain stability if needed, though the sort order is primarily driven by your greedy logic. Third integer, selected part, greedy metric. Physically moving bytes in the string, which is expensive. You construct a sequence of views representing the final layout. Okay. Fox, dog, and quick. Sort selected greedily. Like lexicographical, just general what I'm doing. Identify fill segments, gaps between selected items and the original. Sort selected by original position to find gaps easily. Original order. Track all intervals. Manually define the fills. Fills are sorted by position. Okay. Reorganize, interleave sorted, selected around fixed fills. Find the slots. Fills stay fixed. Selected items before this fill. Hmm. That's a little bit confusing, huh? Um, hmm. Similar. Could give an index to each of the selected fill elements be the third integer, and then sort the selected elements as previously described. Would rearrange their third integer values. Could then, with the integer index values of the selected elements already saved somewhere, could then overwrite those values in the permutation. From there, then select either a fill or a selected value section. Depending on which index in the queue and their respective queues match section appending next. Able to follow me. Hopefully this makes sense. Follow you perfectly. Okay. Merge-like reconstruction algorithm driven by a permutation of indices instead of physically moving data and managing complex pointers during the sort. Tag every segment selected and fill with its original start index or third integer. Sort only the selected list, which shuffles their tags. Reconstruct the final string by iterating through the target positions. Check into this next required index belong to the fill queue or the shuffled selected queue. Effectively a stable merge where the fill queue remains static, sorted by the original index, and the selected queue is sorted by your greedy criteria. You know, sometimes the AI is like a lot to keep it under. What's up, channel C55? Howdy. I have to say, sometimes the AI is just really good at describing what I'm thinking. Like, it's a lot more words than I had available to describe all this at the moment. But that really helped a lot. Yeah, that's what I was going for. Okay. Index-driven merge. Two queues or iterators, fill queues, sorted by the original index unchanged, sorted by agreed logic shuffle. Reconstruct the result by comparing the original index of the head of both queues against the next expected index, or simply by knowing the sequence of segments. Iterate through the sequence once, checking the head of the two sorted lists or queues at constant time, just pushing pointers into a result vector. Every segment has a unique original index, and you know the original order of segments, the skeleton of the string. You can deterministically pull from the correct queue. Excuse me. Contiguous and cover the gaps. Storing it makes the merge logic uniform. Both queues become streams of segments with an ID, and you just match the ID with the expected skeleton. Yes. Yes. Cool. All right. Reasonable algorithm. Pair of views and integers support this reasonably well. I think it works. Let's try it. Okay. Let's try it. So quite a bit more sophisticated than my original idea here. But hopefully correct and hopefully efficient enough for the desired solution. So we're going to use string views. Okay, so we're going to say int I is 0, I is less than size, increment I, j is I, is less than size, j. We're going to say int ones 0, ones plus equals s of I equals 1. And then ones minus equals s of I 0. But we call it balance, it's probably better. Okay. So if then balance is greater than or equal to 0. If balance equals 0, then we're going to have a vector of pairs of string views and integers. And this is going to be segments. I'm going to say segments dot push back string view, start with -1. That's going to be from I to j minus I plus 1. I think that's how that works with string views. That gives me the index and the length. Okay. And if it goes out of balance, if it goes to a negative balance, then stops there altogether. Okay. Interesting. So that'll give me the segments. And there are fill segments. These are going to be the selected sections. Selectable. Okay. Now sort them. Selectable section. With const auto A B. It's going to be return a dot first dot size. These are actually it's going to be descending in terms of size. Or the sizes are equal. And A is less than B. So that's this section. Okay, kind of subtle, not too subtle, but that's the basic idea. I need to check string view, construction, constructor, parameters, and getting the size. Okay. So now we're looking for, also let me check something here. Okay. Seems to have got stuck. Try. I'm like really tired. I don't know what happened. Suddenly just became very tired. So yeah, I have so many more hours to go here. String view is a lightweight, non-owning view. Stores a pointer in size. Okay. Creates empty view. So okay. Excuse me. Dot size works. Okay. Okay. So I need so size is correct. These are both 8 at first, actually. And they're also it's gonna be S step again. What's that? Okay. So we greedily select the selectable sections. Now the question is, I think I need to. Oh, that's interesting. Okay. Excuse me. Yeah, there's a part that's missing here that I was struggling to kind of think through. That was once I have the sequence that I want, the problem is that I've got to select those first. Then I've got to figure out where those were originally in the array. That's where it gets complicated. Okay. The greedy selection is already where they're supposed to be. I don't need the original. I don't need the original. Oh no, I do. Oh, this is not that easy. Okay, this is fair for it to be a hard question. I still should have come up with this. I think it works, but oh man, it's so it's so complicated. Excuse me. Mm. Mm. Okay. Oh boy. All right. Uh. Okay. I guess we're also having some buffering issues too as well. Let me see here. Yeah, it's working. It's just buffering. Okay, so Let me try to work through this again, how it could work. Oh man. Oh boy. We create this sequence, we figure out which sections I want greedily. Then the problem with that is it's going to be sort of an out of order sort. It's not going to be sorted, I guess, the way that I would prefer it to be sorted. So then I guess I would just take that selected sequence, sort it again based off of the beginning index, and then I can go scan left to right through the string to create the kind of fill segments and assign IDs to them as well. Yeah. Ugh. Excuse me. Selecting the sequence in a greedy way is also not the most obvious thing too, because I'm selecting those intervals out of order again as well, which is confusing. This is not so easy, is it? Oh, no. It's not that it's a particularly challenging question to comprehend. It's just really a lot of extra details involved. I'm sure there's a way to simplify this, but kind of at first glance what you could do to solve this. I'm gonna turn off the camera and just kind of rest my eyes for a minute. Just kind of ponder this a little bit more. Oh man. Okay. So I think in order to efficiently determine whether or not the next element that I'm considering will fit in my set of selected subsequence subarrays in order to figure out whether or not the next element will fit or not. I think I should use a set and search for the indices in the set. Yeah, which actually the sorting at the end anyway is going to be these sequences and yeah, okay, so that kind of works. It's confusing, but that does work. Does work. Okay, got it. Yeah, I don't. Man. Um, challenging question, man. It's kind of I don't know. I'm like more tired than anything else. I don't know what it is. Just suddenly, as soon as I have to exert, as soon as I have to like really think about it, I'm like, oh, I'm tired. I'm tired. Okay. So let's continue here. So how are we doing with stream health? Some buffering, I think. Yeah, a lot of buffering. Okay. Let's use a set then. And this is going to be a set of basically these pairs of string views, selectable portions. I don't know if they need to be. I think they could just. I don't think they need to be pairs just yet. Quite frankly, could just be string views. Excuse me. Excuse me. Okay, now I can create just a set of string views. And these are going to be selected, not selectable, but selected. And now I would say for int I0, I is less than selectable size, increment I. And that's a vector, yeah, okay. I would say, now this needs to have a custom const auto comp. Can I do it this way? I can try. It's going to be a it's not lexicographical. It's going to be pointer to index. Um, so this is going to be sorted by the starting index of the string views. Data. Oh, no, I'm looking for determine. See if it understands what I'm suggesting. Wait, what? Huh. Oh, all right. Oh, that's what I was thinking of. I was like, wait a minute, can I do this? I don't know actually if I'm going to go the full 8 hours in one stream. I might just go 2 hours at a time. Just 2 hour sections. Yeah. So this is actually kind of correct. Okay. Then I would say, um, hmm, excuse me. Okay. So I've got this potential new view to add. I'm going to search in the set of views that I already have based on the starting point. And I'm going to say, okay, this is going to be, I think, upper bound. It's not find exactly. It's going to be upper. So upper bound is greater than, and lower bound is greater than or equal. So I think it's lower bound. Oh, it's upper bound. Yeah, it's upper bound. It can't be equal. First element that's larger. And it could go off the edge or not. Now, if it's not at the beginning, then we can set auto previous pointer equals pointer or decrement or previous of previous pointer. So we'll go back and find the element just before where this is going to be inserted. That's one way of doing it. Or if there is no element, or rather we got to the beginning of selected. Maybe there is no previous pointer to work with. Hold on. Actually, I need to think about this a little bit more. If it's empty, we'll do one thing. If it's not empty, I should probably handle that case first. Okay. Yes, maybe not. Okay, so we'll do one thing if it's empty. We'll do something different if it's not empty and it's not the beginning. And then if it's not empty, but we are at the beginning. Yeah, if we're not at the beginning, then we're going to be between two different sections, and I've got to check that this interval fits between those two sections, the previous as well as the one that was found. If we are at the beginning, then I just need to make sure the one that was found is this interval will fit with regard to that one. If it's empty, I don't have to check anything. Okay, I think that's probably fair. So if it's empty, we would just say selected dot insert BW and move on. If we're not at the beginning, then we've got to check const bool fits left is going to be equal to the left side is going to be I need to check that the right index, which is going to be the previous pointer data minus s.begin plus we're going to do const int left index. This pointer data minus s.begin. This left index plus size, this previous pointer size, dereference. So if it's like, let's say it's starting from index 1 and it's size 2, 1, 2, 3, -1, I think. That is the index. It's going to be size -1 plus the left index. That has to be strictly less than the VW target index. Okay. This has to be strictly less than the target index. All right. Yeah. And then there's the right index, which is going to be not the previous pointer, but just the pointer. Minus this begin. And then we're going to say fit right. If it's right, that means that the target index plus pointer size -1, that has to be strictly to the left of the right index. Okay. Confusing, but that's what's required here to check. And so if fits left and fits right, then we say selected insert VW. Okay. Okay. All right. That's the check. And similar check has to be performed if we're at the front. Easier said than done, man. This idea that I had up to this point, easier said than done, for sure. For sure. Okay, so it's not buffering as much now, which is great. It's still buffering a little bit, but not as much. Yeah, I think I will actually break this into two into 2-hour subsections. Okay. So I just copied the left and the right side. So when it is the beginning, there is no left side to consider. That's why we dump all of this. Dump all of that. Just consider the right index. Okay. All right. So that's the greedy selection approach. That's fairly straightforward. And there is something more to this. Okay. So now that we've created our selectable sections, and then we've selected greedily those sections, the next thing to do is I think I need to assign each of those string views integers, numbers, left to right. And sort again using the same sort routine that I had used here. Not this one, this one. Sort again with this routine. What was been selected, sorted again. First, assign them all numbers left to right in the set. Dump them back into a vector. Assign them values. Now, what's going to happen here is the fill views are also going to be considered. So, basically, if the view that I'm looking at in the set isn't the if it doesn't start the string, then I've got to create a fill. If there's any gaps, I guess if there are any gaps between the elements in the selected section, then those parts of the string are going to be put into fill views. And then those fill views are going to get their own, they're going to get indices that are interleaved with the selected indices. So I'll have a counter going. And when I fill, I assign the index and then increment the counter. And then when I don't have a fill, when it's a selected section, then I assign the counter, the counter value, and then increment the counter. And so in this way, I could put I can create the fill views and create an array of fill views, and then I could also put the selected views into another array. Both of these will be vectors. And then those will be pairs of views with integers. So the pairs will automatically have the index associated with them. And I'll also keep, I think, an array of the fill indices or the fill tags, as well as the selected tags separately. Keep that another vector separate of those things. And then what I can do is sort lexicographically again the selected pairs, sort them by their views, not by their indices. Now the indices will be out of order, and then now I can reassign the indices from the array of indices that I had before. Or I don't even need to have pairs like that. I can just have the array of indices of the fill and the selected intervals, and then work through those in tandem while I'm working through the index arrays or the tag arrays. And if I do it that way, it's implicit which tags belong to which string view, and I don't need to pair them up explicitly. That actually is a little bit easier, I think. Let's do it that way. Yeah, and then I would just do a loop, grabbing, depending, looping through the tags, pick the right one. Very interesting. And then reconstruct the original string based off of that tagging. This is a bit complicated. It's a bit complicated. Maybe not the best solution. I think I need to ponder this a bit. Definitely pretty challenging overall. So let's see here. Not buffering as much as before, which is good. I think while this is a reasonable approach, It's pretty complicated, pretty involved, and I would guess that there's a better way to do this. I think this will work, but it's a pretty it's a bit of a brute force solution in a lot of ways. But yeah, setting up the tags is probably what I need to do next. So in order to do that, I'm going to walk left to right through. So we'll do stud vector int. We'll do two things: to stud string view, stud vector int. We'll say fill tags, and we'll say selected tags. And this is going to be fill views, fill views. Okay. So now we're going to say from int I is 0, less than s dot size, increment I. Say if say pointer auto pointer equals selected dot begin. If pointer is not equal to selected dot end, and I is less than pointer data. So we're going to say, okay, hold on. Index is going to be pointer data minus s dot size, s dot in. If I is less than index, then we're going to create a fill. I is equal to index. So if I is less than index, we're going to set I equal to index minus 1. And we're going to say fill dot pushback s dot begin plus I, and it's going to be ix minus I. Really, it's going to be ix minus 1 minus I plus 1, but that just becomes ix minus I. Okay. And it's going to be fill views. So we're going to create that fill view. And also, we're going to say int tag count. Starts off at 0. We're going to say fill tags dot pushback tag count. We're going to increment the tag count, and we're going to move index I all the way over to the next selection. Okay. Now, if we are at the next selection already, then we're not going to modify. Oh, actually, I do need fill views, selected views. It's more like selected array, but I'm not sure. I probably should be selected array. Selected vector. We'll do selected vector dot pushback. So this is going to take it out of this set data structure. Pointer, yeah, just dereference the pointer. Okay. And we say selected tags, pushback, tag count, increment the tag count. Okay, also I is going to plus equals index plus pointer size -1, I think. So it's going to jump that section of the text as well. So like if it's 3 characters, we start at index, let's say index 1, 3 characters should be 1, 2, 3, and then we should jump to 4. So, but there's going to be a +1 over here. So that's why I'm going to leave it just -1. Same reason why I did this over here. So that's if the, and this selected vector pointer also next the pointer as well. So this moves forward. Okay. That'll give me the fill views and the fill tags, as well as the selected vector views and the selected tags in the right order, the right sequence. So the next thing is, if it is the end here. So otherwise, the pointer is at the end. And I is not at size, obviously. Then we've got to fill the size. So it's just going to be the fill routine without this extra code, extra stuff. So we would fill views, pushback, SVN plus I all the way to, it's going to be s.size minus I plus 1, which is actually s.size minus 1, s.size minus 1 minus I plus 1, just gives me just s.size minus 1 minus I. Tag count, increment the tag count, and then I ends up being s.size minus 1. Okay. That'll give me the tags set up appropriately. And then now I've got to sort the selected vector. Again, same routine I used up here. Excuse me. Same routine, but now when I create the results, things get a lot more interesting. So now I have these tags, but the vector is, and I have the tag count too, which is cool. And I can hopefully use these tags to organize things appropriately. So if so we're gonna just do like J and K as well. If fill tags of J equals I, let's do this. If selected tags of K equals I, then do this. And I think in this case, we will increment J, and here we will increment K. And we're going to say take result and add to it the fill views of J. Same thing, result plus equals the selected vector of K. And we just kind of jockey between the two and add them to the result and then return the result. And I'm not sure if this works. Probably not. It's like 100 lines of code. It's messy. I'm sure there are typos. I'm in high school right now. I can only dream of coding like this right now. What's up, Doom's Music? How's it going? I mean, this isn't too crazy here. This is just, be quite honest with you, this is probably not the best way to program something. This is like, I just tried to come up with a solution that could work. But it really took me a while. It took me like an hour now to like kind of try to think this through. And I kind of went through it a little bit with an AI as well to try to help me out. So it's definitely, not something to envy. Not something to envy. But if I could inspire you to take a greater interest in programming, that's not such a bad thing. Although I wouldn't recommend it as a career choice. It's really difficult as a career choice, but it's pretty good as something that you're interested in doing. You can make money doing it. I shouldn't say that. It's just a hard career choice. You can do it. It's just tough. There's just a lot to think about when it comes to this sort of thing. A lot to consider. Okay, so apparently this doesn't quite work the way I'd like it to. So I'm not familiar very much with string views. I don't use them very much. So small errors like this, I won't quite know what's going on. Or won't know why I'm seeing these issues. So can't convert initializer list argument to const value type. Huh. Cannot convert initializer list argument. Maybe I need to explicitly make this a string view. Let's see, what does it say? Critical bug SI instead of SJ. Oh, all right. Sure, that's true. I made that mistake before. But that's not the thing I'm concerned about. I'm actually concerned about the compiler error. Okay. Constructor usage is correct. This approach efficiently identifies valid dict path substrings. The dict path substrings. Yeah, that's what we're looking for. The dict path. Always. I don't know if it's better to call it a dike path. The dick path or the dike path. I think either way. It's not much better. Oh, that's funny. Jeez, man. Whoops. Oh, didn't mean to do that. Taking iterators were removed. No. Oh, that's a bummer. Oh, no kidding. Okay. All right. Yes, that's that data. Oh, all right. Oh, that's a real bummer. Okay. Gee, I wasn't expecting that. Oh, that's a bummer. Um. Okay then. Let's see. So this is gonna be these all need to be changed. Okay. Let's try this. Huh. There's no constructor that accepts an iterator. Dang. Dang. Okay. And size type. Oh, wow. Okay. And also it wants me to have a size type. Okay. Can't be narrowed. So I needed both of those. All right. That's fine. Sure. Now, the best way to do this is to use a static cast, but it's definitely a bit clunky in terms of the semantics. It's just a lot of typing for something so simple. So I needed both of these changes, huh? Okay. Well, golly gee. Well, golly gee. All right. Do I have anything else here? Just check the. Okay, still compiler errors. Okay. All right. Forgot. Forgot one tiny little thing here. I need a closing. Hey, what is this called? Oh yeah. When it comes to lambda expressions, you're supposed to have a semicolon. It's called a semicolon. Okay. Oh, I can't use it. Oh no. There is a way to do this. It's kind of sophisticated though. Let me see. Uh oh, I think I recall. I was gonna say, I was like, I'm pretty sure I can do this. It's just, I think it goes here. You could do either of those, but I think it goes here. So if you did it this way, you would need to make this a class that has certain properties to it. Um, I forget what it's called exactly, but it's like a functor class, effectively a functor class, something like that. Um, a special kind of a functor class, or you can actually use the function as a parameter to the constructor, and I think this also works, which is kind of cool. I think it's this one I need. Comparator to constructor. A.data minus s.data. Oh, I am going to need to use s.data there, aren't I? Yeah, yeah. Declare type. Okay, this is what I need. This also has a compiler. I don't think, actually. Yeah, let me try this. Let me try it. Okay. Have to use data for everywhere. It's a little confusing. I think I'm going to get more of those errors. It's kind of annoying. But it's okay. Not the worst thing in the world. Kind of subtleties between using data structures, I guess. Okay, I'm sure there's more. No discard. Uh, reference the non-static member. Oh yeah, constant. Where did that go? Oh, it's further down. Here it is. Okay. I don't know what that no discard error is. What's going on there? And the warning, and there's an error. Oh, it's supposed to be a function, that's why. That also matters. Okay. There's probably another mistake somewhere. Or typo. These are all kind of more typos than mistake. Oh, okay, that's a mistake. Buffer overflow is a mistake. That's a logical error. Excuse me, most of these are more semantic issues and typos. Okay. Well, there you go. It gave me a warning about this, so I have to check what these functions do. It might be because of the next and the previous pointers. Yeah, let me check those things. Oh yeah. Okay, let's do this. What does this do? I don't remember exactly what the previous pointer, next pointer does. I think it pushes those pointers forward. Okay, does not move the iterator. Okay. Turns a new iterator. Ooh. Okay, assign the result back to the variable. Got it. I was like, I think that's probably what I'm doing wrong here. That's probably what I'm doing wrong here. It does not move the iterator. Okay. Yeah, on the other side, I'm gonna do the same thing. Here, somewhere here. That's probably correct now. Or it's probably better. Still a runtime error, but at least those mistakes were accounted for. Let's see if the AI can handle this code and can understand what's going on. I doubt it. Or maybe, actually, I don't know. We'll see what it can deduce. This is very complex code overall, though. Okay. So now for debugging. Now to debug this. Oh boy. When did it have the overflow? What line of code? Excuse me, the right index. Ah, there is one more issue here that I missed. Yeah, that's important. That was bad on my part. There is still one more thing here that's important. That's exactly why it's having issues, I think. So this is for when it's not the beginning and it's not the end. And then here is, it's not the beginning, but it basically is the end. So the fits right part shouldn't be checked. There's no right index to check. Yeah. So only if it's left. And then the other side is when we're at the beginning, we have to check if it fits right, but we don't check if it fits left. And then if we're empty, then we don't have to do this. There's actually 4 different conditions to check there, which for some reason I forgot there's 4 of them. For some reason I forgot there's 4. Okay. What is the line? Wait, what? Running to null pointer. Something went wrong. Let's see. Let's run it one more time. I'm actually not sure where this runtime error is occurring now. Okay. Define behavior. Got UV somewhere in the vector. Okay. It's overly complex and likely incorrect. There you go. There you go. Okay. So I'm just trying to get it correct. Hold on. The standard solution. No. Okay, wait. Trying to work through solution. What I'm thinking. Phew. Okay. Very interesting algorithmic experiments. Great way to deeply understand the problem structure. Debugging your logic. Construction loop. The one filling fill views and selected vectors. Critical bug and how you advance the index. Okay, double increment skip. And this block. Logic error. Absolute start index to I. The current. Oh, whoops. Whoops. That's supposed to be an equals. Okay. Yeah, that's a mistake. That's a logical error. That's a very subtle error, though. That would have taken me a long time to find, especially because the debug outputs were a little bit awkward. Yeah, the debug was just giving me just like a basic UB message, and I was like, "What? I don't know what that means." Okay, are there any other bugs it found? Merge logic, reading out of bounds. Right. Wait, what? Check bounds before accessing. Yeah, that's a good point too. That might actually be, could be what's giving me the UB. Didn't even think about that. Oh. Yes, actually that's pretty important. That's like almost certainly gonna give me an out of bounds issue if I don't check that. It's designed actually to. I'm so proud of this too. So proud of what I did there. I was so proud of what I did there. Okay. There we go. Now it's not giving me UB. It's not giving me the right answer, but it's giving me UB. Not giving me UB anymore. Okay. So interesting. Uh-huh. Right. So it looks like I sorted in the wrong direction. Hmm. Didn't touch this one. Okay. Oh, it didn't touch any of them. Didn't do anything. Oh. Interesting. Okay, let me seem to be getting back. Original string. What do you think? Huh. I don't know why I'm getting back the original string. That's weird. That's weird. Exact same substrings that already exist in the string in their original relative order. All valid special substrings, including nested ones like 1, 0 inside 1, 1, 0, 0. Okay. Sorts them by size, lexicographical order. Try to fit them into the selected set without overlapping. Gets picked first, it blocks everything else. Oh. Oh. Consecutive special substrings. The parts are consecutive. Independent items to be placed in gaps. Original string, they're adjacent, there's no fill between them. Oh, I goofed. I fundamentally misunderstood the question. Swappable parts are only directly adjacent, not nearby. Fillable filling characters between. Okay. Dense and recursive. Oh, never filler character. Oh my gosh. Okay. Let's see. I like valid parentheses. Oh gosh. Okay. You can only swap consecutive special strings. Substrings cannot move a substring across the filler text. Recursion is mandatory, is defined. Special. 1 plus interspecial plus 0. You must maximize the interspecial part before you can correctly sort the outer layer. Solving a much harder and different problem, placing items in the gaps. The actual problem is simply decompose, recurse, sort, neighbors, concatenate. Simplifies your code drastically. No need to fill views, complex index tagging, or overlap checking. Just use a simple recursive loop. Of course. Oh man. Oh no. What happened? I might want to. Man. Oh, did I struggle? Man, oh man, oh man. That's a rough one. So, what did I learn today? Well, it's funny when I use the AI, it just like interrupts me when I'm going off the rails with my thinking. Not off the rails, but off into areas that are not helpful or useful. What yeah, we're still live. Okay. Oh man, it's difficult, huh? Basically, when I start solving the wrong problem, not off the rails, but off into start solving the wrong problem, then helps me bring me back. Okay, so let's start over. This is not the correct solution. It's an interesting idea, but not right. Okay, trying again. Okay, so I can swap 2 consecutive non-empty special substrings. All right. Okay. If there are 4 or 5 special substrings in a sequence, then I would want to sort. That's fair. Decompose into its top level consecutive components. Strings effectively concatenation. Any 2 adjacent special substrings can be swapped to perform any number of swaps to reorder the entire sequence analogous to bubble sort. Maximize the result lexicographically. You should simply sort the list of decomposed substrings in descending order. Sort them descending gives concatenating them yields the largest possible string. For sorting, cursively apply the same logic to the inside of each substring. The substring might internally become, after its own inner parts are sorted, change its rank in the outer sort. Okay. So, part of the recursion is noting that a subspecial binary string has to form 1 plus special substring plus 0. Fair. Partially fair. 2 possible forms. A and B are non-empty nesting. Okay, why the distinction matters. The nesting case. Primitive special strings can be split further. Many special strings are concatenations of smaller ones. The string does not start with 1 and end with 0 in a way that wraps a single special substring wraps 2. Okay, processing a string. Try to split it into consecutive special substrings. It cannot be split as primitive, then it must be of a form. Strip the cursor up and back. The form is the base case. Okay. So those 2 rules. 1 plus A plus 0 and C equals A plus B are produce the closure of special binary strings. Is that fair? Fair and mathematically precise. Those 2 production rules define the closure of special binary strings equivalent to dict paths or valid parentheses sequences. Formal grammar can define the set of special binary strings recursively. In base case, empty string is special. Nesting rule of A is element of S, then 1 plus A plus 0 is element of S, creates a primitive block. Concatenation rule, if A is element of S and B is element of S, then A plus B is an element of S. Confirms a sorting strategy. Non-empty special string can be uniquely decomposed into a sequence of primitive blocks. Each primitive block must have this form. The algorithm is split S into primitives. Each P sub I strip the outer 1 and 0, recursively solve for A sub I and rewrap. Sort the resulting list of process primitives in descending order, concatenate them. Oh. So my algorithm wasn't too far off. less. Hmm. So I was close actually. It wasn't irrational what I was thinking of. It was just not like not totally correct. It's just a little bit off. Interval packing logic fails because of nesting. Yeah. Handles the hierarchy naturally, split the string into top level blocks, A, B, and C. Recurse before deciding where A goes. You strip its outer 1 and 0 and solve the problem for its inner content. This ensures the inside of A is maximized first. Inner parts never compete for space with the outer shell, they are part of it. Okay. Sort these blocks by size value, concatenate them. Recursive boundary. Interesting. Yeah, okay. Got it. Oh, very interesting. Flattening recursion to iterative approach likely allows for linear time supposed to it's probably correct. Let me try that. Okay, so this actually was a lot easier than I realized. I just didn't see it. The key parts. So, um, it has two forms. It's either a combination of two special strings, or it's a primitive special string, um, or a primitive extension of a special string. Hmm. Um, Let me see here. I could do the primitive approach here, or I could choose. I'm trying to think what the recursion should pick. Um, I could do both actually. That's actually probably recursive approach works. Okay. And so to recurse. So oops. Um let's do it like this. Constant left index and a right index. Basically it's gonna be like a string view. Yeah, that's fine, I suppose. So this will be basically 0 to s.size plus 1. And I'm also going to include also going to include self. No, this auto double reference self. And oh yeah, what would the AI think? Potentially lead to a linear time solution. Oh. Sorry about that. Okay. Typical recursive approach is quadratic. Not sorting. Linear time solution is theoretically possible using suffix array construction with the prefix doubling algorithm, but it's significantly more complex than the standard recursive method is not typically used for this problem. Oh, interesting. Suffix array, prefix doubling algorithm could yield linear time solution. Cool. That's awesome. Cool, very cool. All right. So let's try to do the recursive solution because I'm not doing the suffix tree, all that stuff. We're not doing that for this question. Let's do okay, you've got a few options here. We've got for int I equals left to I is less than right. Increment I. So we have stood string okay, simple would be recurse on so 1 plus self. I think this yeah, well the 0 and it's going to be left plus 1, right minus 1. There's a base case if left is greater than or equal to right, or left is greater than right, then just return an empty string. Okay, so I've got the simple case, and then I've got the string result. Starts off as simple. And we're going to return result. And we're going to say for each index left plus 1 and I plus 1 less than or equal to right, we're going to say recurse on the left side plus recurse on the right side. And I think it's got to be at least 2 characters, so we can always do at least, well, we'll do at least two characters. at a time. No. Yeah, it's at least 2 characters on the left side. Because it can't be, yeah, okay. So we're gonna say results equals stood min of the left side and the right side, which is gonna be I to something, and then yeah, to the rest of the right side. So it's going to be the left side to I, and from I plus 1 to the right side. Okay, a little confusing, but this is the recursion. And this can be used dynamic programming to memoize this. So that's efficient. So we would say memo. It's going to be stood string memo of s.size, s.size. This might need to be like a vector. Yeah, it's got to be. There's a couple ways to do this. I'm gonna just use a vector for this right now, but there's a way that this could be done that's not too bad. I think I can use an array. Yeah, there are other ways to do this. We'll just leave it for now. All right. How does this work? It's just a regular vector is stood size empty strings, but this is going to be it's going to be s size of these vectors. Yeah, okay. A little confusing, but yeah, we're going to use that. And we're going to say, yeah, okay. I'm not sure if this is the best way to do it, but actually, you know what? Let's do it this way. I like this better. We use stood pairs. So it'll be string bool. That's going to be empty string false. So say if memo of left right is second. It's true. And we return memo of left right first. And we're going to set before I return anything, I'm going to set these to so that's true. Okay, something like this I think works. It's a bit convoluted, but I think it works. Yeah. It's n log square n or n log n, not linear. Okay. Don't strictly give an n log O of n solution. Okay. True linear algorithms. Algorithms like difference cover modulo 3 or SAIS can build a suffix array of n. However, suffix array sorts all suffixes. Your problem requires sorting special substrings, which are specific ranges and handling recursive nesting. Mapping the recursive structure of special strings onto a flat suffix array to achieve linear total time is an open and extremely complex research challenge, not a standard application. Oh, okay. I see. O(n) squared is the standard recursive solution. Behaves close to n log n on average, given that n is typically small. Recursive approach is preferred for its simplicity and readability. Achieving true linear time would likely require a novel algorithm combining suffix automated or suffix trees with linear time traversal strategy to handle the nesting. It's far beyond the scope of a standard interview question. Okay. Well, there you go. And I got a compiler. Okay. And I got a compiler. All right. Interesting. How are we doing here? I think I'm gonna take a break around 3 hours here. It's definitely a tough question. So this has been a learning experience for me, for sure. For sure, a learning experience. Very interesting question. Oh, shoot, I need to do that. Okay. Yeah. Interesting stuff. Okay, compiler error. Oh, just missing some. Okay. I need another one of these, I think. Gets a little bit complicated when you start nesting too many things. Got a pair instead of a vector here. Which this needs to be now a pair of stood pairs of strings and booleans. Okay. Pair, oh, that's comma. All right. Must be call. That's true. That's true. Return auto constructor. All right, so this should probably be a stood string here, which I could just put here. I don't know why it's blue now, but okay. Turned blue on me, man. Okay, compiler. Function called a min. Oh, there is a mistake here, slight error. Result. Let's do it like this. There we go. Yeah, a lot of minor details that I kind of, oh, it's wrong too. Okay. Okay. Interesting. Okay. Surprised it's wrong. Okay. It's memoized, so it should be quadratic time. Instead of exponential. Hmm. I wonder if this makes sense. I don't think so. I'm curious if maybe that's the error. That doesn't quite make sense to me. No. No. Okay. I think you gotta have at least 2 characters on the right side. Well, the left side, at least 2 characters makes sense. On the right side, like if I did right -2, this would give me right plus. I think this could be a 1 though. No. No, it cannot. No, it cannot. Not quite sure where the recursion is wrong. It's gotta be something that I didn't realize, something I missed. Hmm. I could do this and just say if left minus right is less than 2. That might be easier to just use simpler logic and just remove. Oh, something happened here. Okay, that's all wrong. Oh, all right. A little surprised there. I'm not sure what's going on there exactly, but a single character. It really should be +1 is less than 2. It should be less than 1. And it should be right minus left. I didn't think about that actually. If it's less than 2, less than 1. Yeah, something like this. Okay. That avoids the runtime errors. Oh, interesting. There is a subtlety here. I can't use a standard min. That might be the issue. I think these are strings. So a dot size is less than b dot size, or is greater than b dot size. So I'm gonna optimize for the larger size, or they're equal, but a is smaller lexicographically. Let's try that. I don't know if min has a custom comparator like this. I'm gonna assume it does. No, still wrong. Huh. Hmm. All right, I'm gonna throw this into the AI because I don't want to spend too much time thinking about this. I did something silly here, but I don't quite know what I did. Uh, mm, I think the issue is these need to be valid. I think these need to be valid strings. Um, yeah, okay. Um, hmm. Maybe this is what I need, something like this. Okay. This is probably more complicated than it needs to be. Okay. Um, hmm. Oh, I see. Okay. Excuse me. All right. Not sure if this is going to work. I could try this. There are a bunch of things going on here that I'm not so sure about. Fundamental flaw. Yeah, there's quite a few flaws here. There are quite a few flaws here. I think this is just going to be... Yeah, I don't know about this one. I'm trying different things to see if I can get something that works, but this is pretty awkward, actually. Okay. Okay, it's 90. Okay, 99 milliseconds, and it's wrong. And these all just give me the same values. I think they all give me the same wrong output. Oh, oh boy. Okay. Um, hmm. Maybe this is what I need. No, still 98 milliseconds. What is going on with this, man? This is crazy. It always returns false, I think, is the issue here. I think actually call these true. True by default. Maybe that's part of the issue. Still wrong answer, but oh, this is okay. I don't know, man. Okay. All right. I probably need to rewrite this. This is very confusing. Yeah, it's a bit of a mess. It's a bit of a mess. Okay, what let's see. Prevent it from producing the correct answer, incorrect recurrence. Try to minimize the result using comparator that sorts by size first. Lexicographically largest string. Is it largest or smallest? Decompose the string into top-level special substrings. Recursively maximize each one and then sort them in descending order before concatenating. Misunderstood decomposition. Split the string in every possible I, which is not how special strings work. It should only split when a complete substring is found when the balance counter hits 0. Simpler and doesn't require a 2D memo table. Okay, wait. Don't give me solution. Trying to figure this out. Or I tried the standard approach. All right. So there's something important here. Okay. So we could do left if, now we can use if left is less than right. Okay. The lexicographically largest. I think it's lexicographically smallest. This logic is kind of confusing, this part. Right size, left size. So if the if the size is larger, it should be, I think, on the left side. Yeah, if the sizes are equal, though. Then we want A less than B or left less than right. Or right is less than left. Then we swap these left and right. And then we say left plus right. Okay, maybe this is something that I want. I kind of forgot about the swapping involved. These don't need to be const, not necessarily. Non-cons can all right. Fine. Doing some copying things going on here, but it's okay. Boy. All right. This approach is not the best. Overly complex, simpler, more efficient. It can decompose the string into top-level substrings, and the balance counter at 0. For each such substring, you recursively process its interior between 1 and 0, then sort all process substrings in descending order before decaying. This approach naturally handles the nesting structure and ensures the lexicographically largest result. DP solution attempts to consider all possible splits is not necessary since the balance counter naturally identifies the correct decomposition. Points. The time complexity of standard recursive approach is quadratic due to sorting, which is acceptable given the constraints. Overly complex is logic errors, maximization problem. It's 0. Is it the lexicographically largest? Oh, it is lexicographically largest. Oh my gosh. I don't know why I missed that too. I don't know, man. I've been struggling with this question. It's tough. It's definitely a tough one for me, it seems. I don't know why I missed. It's supposed to be. What we do is still buffering, I think, a lot. Yeah, a little bit of buffer. It's actually quite a bit of buffering now. I should take a break soon, though, for sure. Yeah, so lexicographically largest definitely makes a big difference here. This part is just larger, smaller now. Okay. But I got completely demolished by this question. I really struggled with this question. Huh. This does not give the correct answer. Hmm. Oh. Okay. I think this needs to have a 2 and a 2 here. I don't quite understand why, but I think that's true. Otherwise, I run into trouble. Why does this? Some reason this will just put all of the ones. Huh. I don't really know why. Uh. Hmm. Overly complex. Yeah. Every possible balance at 0 equally doesn't reflect the nested parentheses like nature of special binary strings. Correct approaches decompose the string at the top level of special substrings and the balance counter reaches 0 recursive. Doesn't the Oh, I see the problem. Oh, I see the issue. Simple case can't. Oh, that's actually kind of subtle. This is only possible if left equals 1 and right equals 0. Then we do this logic. Okay. That's important. I was gonna say, I was like, if these other two production rules give me the entire algorithm, then this should be fine. Yeah, it's part of the. Oh, now it's correct. Gonna go for it. This may or may not be correct. Hopefully it's correct. Nervous. Of course not. Yeah, it's kind of complex. I probably shouldn't have submitted that, quite frankly. Probably should have just tested more things first. Okay. All right. Oh, I probably should have just done a little more testing. I would have found the issue. Okay. Not correctly decomposing the string. I do need to take a break soon. Thought. Hmm. Huh. Hmm. Huh. Oh, okay. Starting to run out of context here, or the context window. Yeah, these production rules should allow me to do this implicitly. If they form a closure, which means my code is okay. Okay, got it. It is a typo in the code or something that I missed. It could be something more subtle. I think I need to start a new conversation. Let's go really slow. So there's some logical error here. I don't understand it though. I'm not so sure. Oh, I think I understand. Top level strings. Uh, Interesting. That's an interesting question. Wow. Thank you for identifying that subtlety. Oh, that's a really subtle. That is really subtle. Well, there you go. It's part of the issue. Wow. Okay. I do need to take a break. Okay. Huh. All right, we're gonna open a new conversation. Try again. Dang, man. Yeah, pretty tough overall. Pretty tough. So, um, this was wrong. This was wrong. So let's try again. Let's try again. Okay. Tempted. Okay. All right. We're gonna use const auto curse. Oops. We'll return the recursion back to what it does in a moment. We're gonna have a left side and a right side that we're gonna split. Excuse me. Split the string into two pieces. Gonna return a string for now, although it could be something else. Slightly different than a string. I can say if left is greater than right, just return an empty string. In the base case, simple case, if s of left equals 1 and s of right equals 0, then we have a start our result off as 1 plus self plus 0. This auto self. This is going to be left plus 1, right plus 1. Okay. So that's the base case. And then we say for int I equals left, I is less than equal right, when I understood vector of strings. These could be string views. Views. And we're going to say balance. Balance plus equals s of I equals 1. And then subtract the balance. Minus equals 0. So if balance is less than or equal to 0, then we're going to use dot pushback. We're going to say int start. It's fine. Or no. Another for loop here. Oops. Well, actually, balance doesn't need for any 0. Can just okay. All right. It's going to be s dot data plus I to j minus I plus 1. That's when the balance goes down to 0, back to 0. And we break here. We set I equal to j, and we increment j here. We increment I here. Start the next one. Okay. So give me all the views. And then after I get all those views, I can sort those views. Okay, and then now I can return the result as all those views combined. I'm going to say possible. For each view, just add it right onto possible. Okay. Something like this. Just going to try this and see how this goes. Okay, compiler. Oh yeah, I forgot about that. This is a little bit awkward. Doing the views. All right. Let's see how we're doing here. Compiler. Oh. I'm so used to using integers. So used to using integers. Yeah, I don't work with views so often that a lot of this mechanical stuff is like kind of not super familiar to me. Okay, it's wrong. Of course. It's really close though. It's just wrong. Oh, man. Jeez, man. Jeez, man. Hmm. Oh. uh. Oh. It's a lot to work through, man. A lot to think about. Yeah, there's a lot of pieces to this. Oh. Excuse me. All right. Just slightly off to the side. Oh, it's so close. It's close. Not right, but it's close. Okay. Okay, let's ask the AI what it thinks before I go too deep. So what I think is happening, I have to analyze the code to figure out what exactly went wrong. It could be that this is just incorrect, the views. I don't think so, though. It's probably fine. This part might be incorrect, too. It could be that this needs to be refined. What does it say? Let's see. Critical logical errors will likely fail. Okay. Incorrect balance logic. Okay. Resets the balance calculation incorrectly. Okay. So the balance logic is wrong, according to the AI. When I see a 1, I increment. When I see a 0, I decrement. When the balance is less than 0. Oh, shoot. Yeah, that is wrong. Oh, actually, I'm not sure if it's totally wrong, because the balance it should be 0 when it breaks here, so actually it would be 0 each time anyway. So that's not actually going to help me there. Oh, okay. Although I could just set it to 0 explicitly here. Okay. Iterate once, increment count for 1, decrement for 0. When count hits 0, complete substring, vessel substring is found. Nested loop and balance reset logic not correctly. Isolate these top level special substrings. I actually think I think it's probably correct, but it's 0. Yeah, I mean it's what it's doing. It's just all right, sure. Fine. Rewrite this so it's a little bit simpler. Actually, hold on. I think this is actually probably okay. It's probably the recursion that's an issue. It might consist of multiple strings. This must be split, processed individually, and sorted, misses this decomposition. Doesn't it do it recursively? Wait. Hold on. Hold on. Content. Further. I think it's giving me wrong answers about why it's wrong. Just kind of annoying. Maybe I'm wrong. Maybe I just don't realize it. Base case and the intent. Decomposition logic is fundamentally broken. Cause the recursion receive incorrect inputs and the wrong answer crashes. It's not correct because they define inner content. String, tire middle, recursor. Often multiple independent substrings concatenated together. Doesn't recursion process both single block and a sequence of blocks? Wouldn't The next iteration is call for both the single block. Yeah, it's I don't think the reasoning it's giving me here is totally correct. Answer is no. What? Ignores internal structure. Call is recursion on the inner content. However, the result of that call is immediately wrapped back up as a single unit. I'm very confused. Confused by this. Suggesting the order of the two sequences. This is wrong, what it's telling me. This is not correct. If what it's telling me is correct, then I could just reorder these two and it would be fine. But that's not at all the issue. It does both of these paths anyway, it shouldn't matter. It's giving me the wrong. No. You're giving the wrong reasoning for what? The two paths, single block, as well as multiple blocks, both handle, don't preclude each other. Oh, you know what? That's why. That's subtle. Okay, that's the issue. I think I figured it out. Not that I figured it out, but it kind of explains it there. Ah, I'm missing the recursion. That's what's missing. Okay, so it eventually got it, but it explained this incorrectly. Um, best, actually processed strings. Let's just say best strings. Data, so it's going to be const int index or left index, bw data minus data And then constant right index is going to be left index plus UW size. That's probably got something to do with it. It's because I don't recurse on all of those intermediate sequences. I think that's the issue. Now I get a deadly signal. Okay. That's great. Okay. What is going on now? What is this? What happened here? How did it even stack? How? How did this even happen? Hmm. But actually, let's not even do views. Let's just do strings. Let's keep this simple. It's gonna be I to j, I think, right? It's gonna be I is the starting point, and j is exactly where it ends. Yes. I'm gonna do that then. Oh man, this has been a rough one for me, huh? Mhm. It has been. It's true. Stack Overflow. I mean, it might just be doing too much recursion at this point. Could very well just be doing too much recursion. Um, oh boy. Come on, really? Yeah. Tried. I don't want to memorize it if I can help it. All right, I'm just memorize it. Keep it simple. All right. Okay. Okay. Mhm. All right, so I memorized it just in case it was genuinely just overflowing. There's too many calculations it's got to do. Nope. No, it's got some other mistake, which is subtle. I've got the memoization in there now anyway. Where? Hmm. Okay. I think the base case for 1-0 might be an issue here. I think it just recurses indefinitely. It does. Yeah, that's what's happening. Okay. Hmm. I think this is also a thing. No, not the issue. Oh. This is like, come on. What did I do, man? What did I do? It's so annoying. Okay. God. My gosh. Yeah. Okay. What in the world's going on here? Why is this happening? Why? What in the world? Okay. Recursive code can be really, really frustrating to debug. It's not my favorite. Definitely not my favorite. All right. So I just get loads of zeros. So yeah, it's a genuine Stack Overflow. It just repeats this loop. It's stuck in a infinite loop here. That's kind of what I thought it might happen. So I is 0, right is whatever it is. Let me actually. Mhm. Oh boy, audible sigh. Audible sigh. All right, let's keep trying. I think. Oh, it's been 4 hours in this question, basically. Okay. What in the world? Why did left end up at 21129? So what did how did that happen? What's going on there? What? What? That's not supposed to happen. What? What? It's supposed to get caught here. If that happens, it's supposed to just return. What in the world? Well, that's not good. Also, why does it have two of these? Hmm. Okay, there we go. I was gonna say, it's like, what is going on? So 2 5 2 2. Okay, I was gonna say, I think I run into issues when left and right are equal to each other. Um, I guess we just do that. Doesn't matter. Still overflows. Oh my gosh, man, this is such a headache. This is so annoying. uh, okay. Oh my goodness. Oh, it's too funny. What is going on? Why? 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 Right. Yeah, now I'm doing some complaining over here. Now I'm doing some whining. All right. What did I do? I don't know. I don't know. What did I do here? Gosh, man. Left, right, left greater than right, left equals right. What's going on with this, man? So, hmm, it doesn't work. Does not work. Right, correct. Does not work. Okay, why doesn't it work? It's got a base case. It's got a couple of base cases. These are probably the correct base cases. Uh, yeah. I mean, these handle the three cases. They can be past each other, they can be on top of each other, or they can be slightly different by one. If they're different by two or more, it should not be an issue. It should be handled by this, no problem. Like, it's got base cases all over the place. Apparently 3 6 was just repeating over and over again. I don't know why. Why was it doing that? Why? So when it had saw 3 6, this should be 2 5 immediately. This should not be an issue. Or excuse me, it should be 4 5 immediately here. That shouldn't be a problem. And then calls balance. Oh, I think I know what happened. Okay. All right. This is subtle. Okay. That's what's going on. Somehow the balance is less than 0. That's that's not supposed to happen. Yeah, that's not supposed to happen. Okay. So for reasons that are beyond me, the balance logic needs to have a little bit more robust handling. Oh, gosh. Why is this happening? This is like, are you kidding me? It's like, okay. I don't know. Something's really weird's going on. It doesn't make sense. Um, no, this is. Oh, I know what I wanted to check. Yeah, I wanted to check S of I. Okay. Oh my gosh, man. This is like, what is going on? Why is this not working? What in the world? Okay. This is supposed to have a comma. All right. So I is 3, J is 3 at this point. And S of I is 1, S of J is 1. Okay, so what's the issue? What is the problem now? Oh, I think I know what's going on. It's going off the edge. So the balance just it keeps incrementing, goes off the edge, and it just keeps repeating this. No, it doesn't repeat. It shouldn't. But I don't understand. I don't know why. Why would this keep looping though? Why would this keep happening? It's in some kind of a loop, but it's directly calling itself. What the heck is going on? What is happening here? Yeah, I don't know. I'm getting kind of tired. I think it's probably the issue. I'm starting to get a little bit, worn out over here. Is this even what it calls it? Yeah, I don't know, man. It's starting to get a little bit, a little weird. It's getting a little weird. Oh, gosh. Oh. People wonder, they're like, Will, what'd you do for the past 10 years? This. wonder why code doesn't work. Just repeatedly. Okay. So we do have calls. All right, they do get called. So it just repeats the same thing. It calls this code and repeats. J is 6, calls 3, 6. This is from 3 to 6, okay. In this test case, it's, excuse me, 0, 1, 2, 3. 0, 1, 2, 3, 4, 5, 3, 4, 5, 6. So it's just cycling over and over on this substring, this 1, 1, 0, 0. I don't know why. I don't know why would that even matter? For some reason. Oh, I guess it does make sense actually. Now I'm thinking about it. Oh. Oh yeah. Okay. Yeah, it's just it's itself over and over again. Oh. Oh. Why why is that happening? um I'm a little confused. I guess I just exclude that case. Oh, all right. Got it. That seems really obvious now that I'm looking at it. That actually seems really simple and obvious. I don't know why I didn't catch that. I don't know. I'm not sure what to make of that though. I don't know what to say in that regard. I'll tell you what, I think part of the issue here is that this is a very unusual algorithm for me. And I'm not used to like throwing in like these kind of complex loops inside of recursion. Like sometimes I do that, but it's pretty rare, and I typically avoid that because it's really complicated. I think that's part of the issue going on here is that like I'm just so unfamiliar with this algorithm and like how to implement it that it's just super awkward, and I'm like really struggling. I'm like, oh man, yeah, I didn't even see that. It's totally blindsided me. I was like, I don't even. And it's wrong. And it's just wrong anyway. It's like, oh my gosh, dude, this is madness. This is so frustrating. I think the AI is just lying to me about what I'm supposed to be doing here, maybe. I don't know. I could be also the issues that the AI is like, it's kind of throwing me, sending me off the guardrails over here, sending me into and it's throwing me into the deep end over here. Maybe I should be, dude, I need a break. It's been 4 hours. I've been on this question for like 4 hours. The first question I solved really quickly. This one is like, this took so much time. This is crazy, man. This is nuts. Ah, so frustrating. This is one of the reasons why you typically want to read the solutions. Mostly don't want to come up with solutions on your own if these are like particularly hard algorithms. That's usually bad idea. Unless you're really familiar with that particular thing. But all right. Lots of complaining. So it's just wrong now. Okay, great. Great. It's just wrong. This is so annoying. This is so frustrating. All right, just tell me what's wrong. Tell me what's wrong. I think I need to take a break, actually. I think I just need to take a break. This is like, oh gosh, dude. Very close. Doesn't feel very close. Okay. Slime breaks the algorithm. No. Ah. Okay. Recurse on the inner part. Oh my gosh. Oh. Oh. So I should. Oh, dude. This is brutal. This is crazy, man. Holy smokes. Gosh darn it. This is nutty. This is freaking nutty. Oh, man. Jeez. Oh. Oh. Okay. How about this one? Oh my gosh. Yeah, man, this is pretty crazy. Pretty crazy. So it suggested just remove that altogether and just combine the two and it won't run into these problems. No, it's right. Of course it is. Of course it's correct now, of course. All right, the AI was not leading me astray. I was wrong about that. Oh my gosh. Finally got it. 3 milliseconds. Not too bad. Dude, that was brutal. That was so brutal. That was so brutal. Oh, it's correct. Okay. This one worked. Wow. Dude. Oh my gosh. Uh, that was rough, man. That was rough. Oh man, this is crazy. This was nuts. This took me so long. Yeah. I don't think I need the memoization too, by the way. I don't think so. I don't need this either, I think. Yeah. Um, oh my gosh. This was crazy. Finally did it. We did it. We did it. We did it. Oh gosh. Ah. Yeah. Okay. Now it's 100%. I got absolutely destroyed by that question. I did. It's true. Gosh, man. Are there some overlapping subproblems? So that's the thing that I was curious about. I guess not. I guess not. Because it goes so fast. If there were, it'd be exponential explosion doing this. I should use parts too. I like that. Parts. This also would just be um hmm. uh, Man, dude, I got absolutely destroyed by this question. Holy smokes. I'm not perfect. I am not perfect. And I'm just a man like everyone else. Human like everyone else, man. That's crazy. That's crazy. Hmm. Okay. Ah. Whoa. This is a little bit cleaner, I think, the code, tighter loop. Easier to understand. Yeah, this code's a lot cleaner. Gosh, man. No overlapping subproblems. Oh, wow. Okay. It's a unique way to be split into top level special substrings. It's still unique. Split points are deterministic. Recursion tree never branches into paths that recalculate the same substring range. Disjoint subproblems. Each recursive call processes strictly inner and disjoint portion of the string relative to its siblings. Split S into A and B, recurse on inner A and inner B. These ranges never overlap with each other with ranges processed in other branches of the recursion tree. Impact of your memorization. Correctness to memorization is correct. It does not break the logic. Zero benefit because every state is visited exactly once. Actually adds slight overhead due to the initialization. It's a pure divide and conquer problem, not a dynamic programming problem. Standard solution without memorization is already optimal at quadratic time. Adding memorization. Okay, so here's an interesting question. Um, here's an interesting question. Would CRTP style optimizations help make these string concatenations faster? I think I forgot what it's called. It's called, but it's effectively fusion. I just set up and compile time. I forgot the name of it. Compile time optimization. So that's it. I mean, there's not much more to it than this. Yeah, you combine the base case and the split case into a single case. Would not help your expression templates. Expression templates. Yeah. Reserve, template metaprogramming technique. Compile time tree of operations, evaluate some simple paths, likely overkill and too complex. Modern libraries that perform this calculate size once, allocate once, logic internally. Strings are tiny. Time sizes. Size of the substrings are only known at runtime. Compile time techniques cannot predict these sizes. It's the sorting per level and string copy, not the allocation overhead. Could do this manually, calculate the total size first, allocate once. Given the constraints, no measurable benefit, more verbose. Hmm. Okay. So using reserve. String was larger. Would reduce all of the string copying. Bring the time complexity. That fair. Okay, so it'd be more like n log n because of the sorting. Not quite fair. Strings slicing, copying, recursion, new substrings. Oh, so the sorting still causes to be overbalanced time. All right. Oh, I see. Huh. Oh, so optimizing the recursion isn't necessarily going to yield better time-bound result. That better time-bound would require fundamental. Would you know of any? Okay, hold on a moment. I need to. I think I need to take a break. I think it's time to take a break. Um, Let me read this, and then I think I'll actually take a break. Memoization or better optimize the recursion itself with memoization or better string handling. It's not going to improve the time bound. Okay. Faster approach. No. Oh. Oh, so they don't. The AI thinks that any approach is not going to be able to do this. Interesting. Oh, cool. For the explanation. So I guess this might be the only solution. I don't know. That's kind of what it was suggesting. Huh. Okay. That was hard. That was hard, man. I struggled with that. Oh, that was brutal. Brutal. Yeah, that was rough. That was a rough one. Said this before, like when it comes to LeetCode style questions, it's way better to learn the algorithms than it is to try to like figure it out on your own. It's too much, broadly speaking. Not that you can't figure this out, but it's like it's pretty involved. It was pretty involved, man. It was a very specific kind of way of doing this. And if you didn't do it that way, it was going to be pretty rough. All right. Well, we did it. Okay. Let's move on. All right. I'm going to take a break here. That was a rough one, man. Thank you for watching Amazing Bro Love from India. What's up, Seshwat? Hey, welcome. I appreciate it. Thank you. Yeah, thank you. You can't see me right now. My lights are out at the moment. But yeah, thank you all for watching today. If you like the stream, don't forget to give it a like and subscribe. I'm probably gonna stream again in a little bit. I'm gonna take a break probably for an hour or two, and then try to do another 3 hours, or maybe do like 3.5, maybe 4 hours. I wanted to do more than one problem today. I did two problems. I did one like very quickly, and then I got to this one, and I just got stuck on it for hours. This was a hard question. It was a tough one. But yeah, let me get going. Thank you for watching. I do appreciate it. And yeah, I should be back on later, a little bit later. But let me get going. Let me get going. This was a doozy, man. Maybe we'll read the next question before I go. Give it a quick read. Of course, that's the one that I I don't have time, man.